So today we're going to do a quick review of both the ductile and brittle failure theories and lay out a guideline on how to select which theory to use for design. Let's start with the summary of ductile theories. We've learned three theories thus far. There's the maximum shear stress theory, where if the maximum shear stress exceeds a certain threshold, then failure occurs. There's the distortion energy theory, also called von Mises stress, where if the distortion strain energy within a body exceeds a certain value, then yielding occurs. And then there's the Ductile Coulomb Mohr theory, where a series of experiments in tension, compression, and torsion are done in order to determine if yielding occurs. Between these three theories, they have different behaviors with the data. The maximum shear stress theory is a fairly conservative theory. It's a great theory to use when you need a little additional safety factor in your design because it predicts failure most often before the experimental failure actually occurs in your structure. So you get additional safety if you design using that equation. The distortion energy theory, that equation, is the most accurate, and it's the best equation to use for general use. When we look at it, it is a non-linear failure surface, and a majority of the data lies within 50% of the predicted stress for failure. That means that this is the most accurate, that it has the most reliability to the actual data. And then our third theory, the Ductile Coulomb Mohr, that is for the special case of tensile compressive asymmetry, where a material may yield in tension at a certain strength, and it will yield in compression at a different strength, and it's not equal. Often we'll see that looking very much like the maximum shear stress theory, except the point of transition for compression or tension are longer or shorter. They're unequal to each other, right? So now let's look at our brittle summary. For brittle failure, this is defined by the tensile strength of a material. So this is literally when rupture or failure occurs in a structure. We have three equations that we've developed. The first one that we have is the maximum normal stress theory, this nice rectangle. And this theory is one of the first theories that are proposed, or the easiest theories to propose, but it's the least accurate. It's only accurate in this first quadrant, and in the fourth quadrant, it is completely inaccurate, meaning it predicts that failure won't occur until a very large stress compared to where failure occurs experimentally, right? Now, to improve upon that method, the Coulomb Mohr theory was developed, which kind of gives us a bit more conservative prediction compared to the experimental data in the fourth quadrant. And then eventually the Modified Mohr theory was introduced that is still slightly conservative, but more accurate to our experimental data. Overall, if we want the most accuracy in a simple model, then Modified Mohr is a pretty good theory for us to use. So now let's then summarize, how do we select which failure theory to use? There is a nice flowchart in our book which kind of breaks things down and helps us to determine which case to use. Let's start with looking at the ductility of our material. If the ductility is greater than 5%, then we should be using a ductile failure theory. If the ductility is less than 5%, then we should be using a brittle theory. Now, if we're using a brittle theory and we want to be conservative, we want a good amount of conservatism to it, meaning we want to predict failure early, we want more safety, then we should use Brittle Coulomb Mohr. But if we want more accuracy to when failure will actually occur, we want to use the Modified Mohr theory. For ductile materials, we have to ask ourselves, is the yield strength and tension and compression the same? Are they equal to each other? If they're not, if we have tensile compressive asymmetry, then we need to use the Ductile Coulomb Mohr theory. But if they are equal to each other, then we have a choice. Do we want conservatism? Do we want more safety in our design? If yes, we'll use the maximum shear stress theory. If no, if instead we want more accuracy, we want to accurately predict the stress at which yielding will occur, then we'll use the distortion energy theory, the von Mises stress. Now, for ductile materials, in general, the von Mises stress is recommended because of its accuracy. It's the default stress that's calculated in finite element analysis. It's how we design complex structures. But maximum shear stress theory is recommended if we need more conservatism. And then for brittle materials, Modified Mohr, it's accurate. It's fairly accurate, not too complex and accurate enough. Well, if we want to be conservative, Brittle Coulomb Mohr theory is the way to go.